Sir, last একটা equation.
Good morning, everyone. So today we see the last part of electromagnetic induction.
Sir, sir, L ওইটা জানি না সেটা করানো স্যার।
আরে বাবা এই তো এতখানি পড়েছিলি, এটা পড়েছিলি তো?
হ্যাঁ স্যার, স্যার L equals to n square mu naught L ওটা পড়িনি স্যার, m এরটা দিয়েছিল।
দ্যাট সেলফ ইন্ডাকশন তো আগেই পড়েছিস।
ও আচ্ছা ঠিক আছে স্যার, ঠিক আছে, সরি স্যার।
এই তো সেলফ ইন্ডাকশন, মিউচুয়াল ইন্ডাকশনের আগে সেলফ ইন্ডাকশন। এই যে সেলফ ইন্ডাকশন।
ওকে স্যার, বুঝে গেছি।
আমি দেখালাম যে দুটো সেলফ ইন্ডাকশন আর দুটো মিউচুয়াল ইন্ডাকশন যদি হয়, মানে as you have two coils here, as you have two coils, so they are mutual of each other for the common part, but individually they are self-induction also, na?
Yes sir.
If you want to find out that self-induction, then how you find? So for the L is the self-induction for the first wire. So for the first coil L1 and second coil L2, the self-induction is this one. And then I show you the formula of self-induction is n square mu naught AL. So for the first coil N1, second coil N2, and mutual induction is both the coil N1 N2. Okay. So we today we first start with some numerical. Okay, from the previous topic. The first question is, what is the self-induction of an air coil solenoid 50 centimeter long? So what is the self-induction of an air core solenoid 50 centimeter long and 2 centimeter radius? If it's radius, if it has 500 tons, if it has 500 tons, so 500 is the total number of ton. So 500 is the total number of ton. We know self-induction, the formula is n square mu naught AL, or we can multiply it by L and then n square mu naught A by L. So 500 square mu naught 4 pi 10 to the power minus 7 area is pi into r square 2 into 10 to the power minus 2 ka whole square by length 50 centimeter, that is 1 by 2. So what you have, what you exactly have, 50 ka square mane dekho 25 into 10 to the power 4, 4 pi 10 to the power minus 7, pi into 4 into 10 to the power minus 7, and you can multiply it by 2. So basically what happened, to 25 into 2, that is 50, into 16 into pi square, and this is 10 to the power minus 7, plus 4 minus 4 you can cancel, so minus 7. Now iska dekho kya ho jayega, 25 50 100 50 50 50 100 200 400 200 400 600 800. So this one is 800 pi square into 10 to the power minus 7. Pi ka square jo hai, you can calculate 3.14 square, which is almost 10. So 8 into 10 to the power minus 7 plus 2 plus 1. That is 8 into 10 to the power minus 4 Henry. Yes or no?
Yes sir.
So this is the first question. Okay, how you find out the self-induction? Obviously they give you the information. Okay? They give you the information, means all things they give you, you just remember the formula. On that basis you can easily find out the question. And that's why I'm always say you 12 is easier than 11. Why? because in 12 it's very predicted, but in 11 is not predicted. Okay, you have to think from your point of view. A large coil, a large circular coil of radius r and a small circular coil of radius smaller. You have two coil, large and small, are put in vicinity of each other. That means this is the large coil and this is the small coil. In vicinity of each other, if the coefficient of mutual induction of their pair equals to 1 millihenry, mutual induction is 1 millihenry, what would be the flux linked with the large coil when a current of 0.5 ampere flows through the smaller coil? So देखो current is 0.5 ampere. So I can suppose this is the first coil, this is the second coil, and what is given? What would be the flux linked with the large coil when a current at this one flows in the smaller coil? So as we know, flux at the second coil due to the first coil, mutual induction into current of the first coil, because it is given for the first coil. So say it's a very simple, whenever you have to find out the flux, mutual induction is same. Now it is depend on for which coil, current in the first coil or current in the second coil. So all the data I have, okay, and it's not required here. So what I can write, 10 to the power minus 3 into half, that is 0.5 into 10 to the power minus 3 Weber, yeah, 0.5 milliweber. Yes or no?
Yes, sir.
Acha. Once we see this type of question, again a theoretical question is very, very important. Again, a theoretical question is very, very important. The question is that, suppose you have two coils, radius r, radius capital R. Okay, let this one number of turn N1, this one number of turn N2. Now the question is that, suppose this one current is I1, and question is that find mutual induction due to outer coil. That means I1 on inner coil. Okay, so I have to find out my magnetic mutual flux up to this coil, yes or no? And here it is given, the capital R is greater than smaller. That means it's almost a point, okay, but not point. Okay, so first of all, for the outer coil, what is the magnetic field inside the coil? Very simple, mu naught I1 to R. Yes or no?
Yes,
Yes
sir.
or no? Achha. When you get this magnetic field, into number of turn, you get the total magnetic field. Now we have to find out the, for that part, magnetic flux. So we know what is the formula? Flux. Suppose at 2 due to 1, because due to 1, see, due to outer coil, so due to 1. So at flux at 2 due to 1, that is mutual, magnetic field at 2, this inner coil, and area of the inner coil, suppose A2. So mu naught I1 to R N1 into pi R square. Yes or no?
Yes, sir.
This one magnetic field into area, magnetic field into area for the each turn, but here total number of turn is how much? अरे दो बात है ना, एक है फ्लक्स each का मतलब क्या, मैग्नेटिक फील्ड इनटू एरिया, एंड टोटल फ्लक्स का क्या मतलब है, flux each into total number of turn, yes or no? So this is the flux each and number of turn kitna, n2, so total flux is into n2, yes or no?
Yes, sir.
Understand? So what we have, mu naught n1 into 2r pi r square into I. Now from definition, what is the definition? Key flux at 2 due to 1 is mutual induction and current of 1. If we compare them, see, if we compare them, mu naught n1 into 2r pi r square I1, I can cancel I1. So what I have, mu naught n1 into 2r into pi r square, yes or no? Yes or no?
Yes, sir.
Okay. After this, this theory is very important. This theory is very important. Sometime what happened? That coil wala question, instead of that coil wala question, here you have that coil wala question. This one, but this is quite a big question, means 3 marks question. Sometimes they ask you. Sometime instead of that large question, they can give you this type of question to check that you actually know the mutual induction or not. Okay, so they can ask you this type of question. The magnetic current is in the outer coil and magnetic field in the inner coil. So find the for outer coil on inner coil, or for inner coil on outer coil, the value is exactly same. Only if they ask you for the inner coil on the outer coil, then this I become I2, which later on cancel out. Rest value is exactly same. Okay. Hello.
Yes, sir.
Okay. So now we move on to the next question. Next question is, an EMF of 0.5 volt. An EMF of 0.5 volt is developed in the secondary coil when current in the primary coil changes from 5 ampere to 2 ampere in 300 milliseconds. Calculate the mutual induction of the two coils. So as I already mentioned, EMF on the secondary coil due to the primary coil, that is minus mutual induction current of the primary, change in current in the primary coil. Why? Because EMF का formula है minus d5 by dt. Yes or no?
Yes, sir.
So my EMF is 0.5 m current final current initial by time, which is minus, I can remove this minus, current initial minus current final by time, that is mutual induction. Initial is 5 ampere, final is 2 ampere, by time is 300 millisecond, and this one is 0.5. So what we can do, 0.5, that is m3 by 3 into 10 to the power minus 1, which is m into 10. So m is 0.5 by 10, that is 1 by 20, that is 0.05. Okay. Okay.
Yes, sir.
Next, question number. A solenoid coil has a 50 turn per centimeter. देखो बड़ा सुंदर क्वेश्चन है. A solenoid coil of 50 turn per centimeter, 50 turns per centimeter, along its length and a cross-sectional area, 4 into 10 to the power minus 4 meter square. 200 turns of another coil. See, the first one is given 50 turns per centimeter, second one is given total turn, how much? 200 turns of the another coil wire, of another coil, the another wire are wound around the first solenoid coaxially. The two coils are electrically insulated each other. Calculate the mutual induction. That means very simple. Mutual induction, they ask you, they given you the information. Okay. So first of all, we know the formula of mutual induction is N1 N2 mu naught AL. But the first problem is that L is not given, right? Yes or no?
Yes, sir.
But see, why they are not giving you L? Because once they give you N1, another one N2, they are given. They are not given you N2 small, means N2 into L. So indirectly, N2 into L, they are giving you the N. Yes or no? That means you can write actually N1 N2 mu naught A. Can we write this?
Yes, sir.
So basically, you don't require this if one is N1, then one is a small n, another one is capital N. So these are a little bit tricky. Sometimes students confuse where is my capital L, where is my length of the solenoid, how to find out the value without length of the solenoid. So for that, remember, total number of turn is the number of turn per unit length into length, and that is the length per unit, number of turn per unit length, not the total number of turn. So N1 is 50, and that is in centimeters. So we try to make it meter. So we have 5,000 per meter. Now we have all the data. 5,000, 200, 4, 5, 10 to the power minus 7, 4 into 10 to the power minus 4. Yes or no? And but we have 4 16 5, and here you have 1 2 3 4 5 5 5 10 10 to the power 6, 10 to the power 6 minus 7 minus 4. You have 16 pi into 6 7 11, 10 to the power minus 5, that is 1.65 into 10 to the power minus 4 Henry. You can write it 1.6 into 3.14 into 10 to the power minus 4 Henry also, but this one is also right. Okay, everyone?
Yes, sir.
After that, one more question which is very, very popular. One more question which is very, very popular. That question is this one. Question is, two coaxial solenoid. This is the first solenoid. Common axis. This is the second solenoid. Now see what happened. For the inner coil, cross-sectional area A1, outer coil cross-sectional area A2, number of turn N1, number of turn N2, length L. Okay, everyone?
Yes, sir.
Hello? So the question is that prove that mutual induction is less than root under L1, L2, and it is given, even clearly visible, given A2 greater than A1. So at least you try this question. I give you 2 minutes for that. So see, this is a very simple question. Let L1 is the self-induction of the first solenoid. So we know the formula N1 square mu naught A1L. If we suppose for the self-induction for the second coil, we know the formula N2 square mu naught A2L. And we know the mutual induction for both the coil N1, N2, mu naught, common area A1 into L. Yes or no? We know this.
Yes, sir.
We know that. We know that. So now if we squaring M square and write L1 by L2, so what happens? N1 square, N2 square, mu naught square, A1 square, L square by N1 square mu naught A1L, N2 square mu naught A2L. Now N1 square, N1 square, N2 square, N2 square, A1 L square cancel, mu square cancel. So what we have, ऊपर में A1, नीचे में A2. Yes or no? Yes or no? And it is given. It is very clear that A2 is greater than A1. It is very clear that A2 is greater than A1. So if A2 is greater than A1, A1 by A2 is less than 1. Yes or no? Yes or no?
Yes, sir.
So as it is less than 1, so what happened? Mutual induction square is L1, L2. So mutual induction is root under L1, L2. Yes or no?
Yes, sir.
The proof. Very simple proof, but very effective proof and very important for your board exam. Okay. Okay. Done, everyone? Yes.
Yes, sir.
Okay. After that, a very small portion left from this chapter. Then we can say we complete this chapter, and then from the next class we start a new chapter. One portion I'm not show you in this chapter, and I show you in the next chapter, that is alternating current में दिखाएगा एडी करंट. ये जो एडी करंट है मैं ये एसी में ट्रांसफार्मर में दिखाऊंगा. ओके, then you understand it in much better form. Okay, so I show you this AD current on the transformer. The rest everything is complete. Okay, एक दो चीज छोटा छोटा बेसिक चीज बाकी है. So I show you that. First of all, कि mutual induction also depends on orientation. Orientation. What do you mean by orientation? Orientation means how you place them. What do you mean by how we place them? Suppose I'm putting two coil. This is the first coil and this is the second coil. So I am putting them in such a way that their magnetic flux is common. Their magnetic flux is common. So in that case, what happened? In that case, what happened? Maximum magnetic field passes through them. Maximum magnetic field passes through them. Means mutual induction is maximum. Yes or no?
Yes, sir.
So is it okay, everyone?
Yes, sir.
Now the second part. This is the primary coil and this is the secondary coil. If we put the primary and secondary coil in that way, see, then what happened? Then the common flux, is what? Minimum, yes or no? So mutual induction is minimum. Yes or no? So
Yes,
the same coil, same number of turns, same length, everything is same, but at the same time, how you place them, that also depend on mutual induction. Yes. That's why the common area, see the common area means here, this is the only common area, right? Through which the magnetic field passes, right? Means one coil. Yes or no?
Yes, sir.
Yes. Third one, see, even if we put first primary coil, if we first put primary coil like this, and in the primary coil, same plate, same common area, because the rest part is the wastage, because we already know the rest part is waste actually. If you see there, it always depend on the it's always depend on this area. So rest area to waste na, because we don't take this as an area for the mutual flux. So what I am taking here, if I am taking the same area, means this area is common for both, and if I am try to put secondary coil in such a way that it is exactly middle of the primary coil. This is my primary, secondary mano, this is my primary. So I2, I1. So in that case, again the mutual induction increase, and this time the mutual induction is more than even the first one, because here there is a chance of some leakage, but here no chance of leakage. Why? See what happened. If we have two parallel wire, like this, two red one or two blue one, so if the current are also in the same direction, so exactly in the middle the magnetic field is 0. So if we put a secondary coil exactly in the middle of the two primary coil, that means if we put a secondary coil exactly in between the primary coil, so then the net magnetic field in the secondary coil is 0, no extra force applied. That means the net system is balanced. That is called the screening effect, meaning no extra heat generated. Okay, so in that case your mutual induction become maximum, maximum का भी maximum, सबसे ज़्यादा. Okay, understand what I want to say? These are the different process in which you can able to increase the value of the maximum mutual induction. Yes or no?
Yes, sir.
And so that means if we put secondary coil exactly in between the two primary coil, then also we can increase the mutual induction. And the most important part is that, the relation between self-induction and mutual induction is called the K, that is M by root under L1, L2. That K is called coupling constant, and this coupling constant is neither exactly 1 nor exactly 0. Why? If it is exactly 1, so it's an ideal case. Ideal case never achieved. Like, see, if you see, neither the first one is ideal nor the second one is ideal. In the first one you get the very large value of mutual induction, and in the or very near about accurate means 1, and here also you get the very near about the accuracy 1. So if we show them ki how much accurate, so I can judge them by the coupling constant. Suppose here the coupling constant is 7, here the coupling constant is 9. So who is more accurate? This one. Whose mutual induction is higher? This one. But they never achieve exactly 1. Understand? 1 का तो मतलब हो गया श्री राम जो exist ही नहीं करता है. ठीक है? Ideal. Okay? Understand?
Yes, sir.
So that's why neither the value of K is 1 nor the value of K is 0. It is always in between. So that's why you can say root under L1, L2 is greater than capital M, or M is less than root under L1, L2. Yes or no? अच्छा, इसके साथ साथ एक और बात कि if we insert some ferromagnetic material, then also mutual induction increase, because mutual induction is directly proportional to mu r. और ferromagnetic का मतलब समझते हो? जैसे मानो तुमने आयरन या कोबाल्ट डाला है, तो मे बी 5000 6000 टाइम्स म्यूचुअल इंडक्शन इंक्रीज. यस,
Yes, sir.
अब तुम बोलोगे सर अगर 5000 टाइम बढ़ गया तब तो के का वैल्यू 1 से ज्यादा होना चाहिए. कैसे होगा? अगर एम 5000 टाइम्स बढ़ा है, L1 L2 भी तो रूट अंडर के अंदर 5000 टाइम्स बढ़ा है. यस और नो?
Yes, sir.
तो कपलिंग कांस्टेंट पे कोई इफेक्ट नहीं पड़ता है, लेकिन मेरा म्यूचुअल इंडक्शन का वैल्यू तो बढ़ रहा है ना. आई कैन एबल टू इंक्रीज द वैल्यू ऑफ द म्यूचुअल इंडक्शन. ठीक है? यस.
Yes, sir.
अच्छा, apart from that, as I already mentioned you कि why as I already mentioned you, why they never give you inductor, means mutual induction and self-inductor, series and parallel. They never give you the overall arrangement in the complex form. Why this one happened? They don't give you the overall value in complex form. I just give you a very small example, then you realize. If I just make it a very simple question also, then also if you want to find out the total inductance, how much complex they are, from that you can realize the examiner never give you both together, because it's a then very much complicated form. So they give you simple structure, and if they ask you, although if they want to ask you series parallel, they have an option resistance and capacitor. But if they want to know you know it or not, they are series or parallel, so they give you the simple structure, because they just check you are know that or not inductor and resistance, they are acting in the same way. They only want to check that one. So suppose I have two coils and I have to find out the net inductance, that is L1 and L2 is given here. And I have one more coil. L1 and L2. And my same thing, my this is figure 1. This is figure. And my main aim to find out the equivalent inductance of in both the case. So in the first case, my equivalent inductance is L1, L2 plus 2M. And for this one, equivalent inductance is L1, L2 minus 2. So now I'm a little bit confused why this happened, why I'm same thing is there, why I'm putting here plus sign, why I'm putting here minus sign. Because here, if you see the pattern, see this one and this one, same direction current flow, yes or no?
Yes, sir.
But here, if you notice the current flow, they are flow in the opposite direction, yes? Yes or no? So when they give you the circuit, means series or parallel, this part also depends in which manner they are acting, series manner, the clockwise, anti-clockwise. So it's so much confusing. For the two, that much complicated. If I give you three, it's more complicated. So they never give you find out the net inductance. If they give you the net induction, only these two questions they can give you, either this one or this one. Only that is the limitation. They give you only these two, not more than that. Because not if they give you more than that, it will be really complicated, and you all don't know. Which you don't know, they don't never give you. Which is not in your syllabus. You are not have any idea how you calculate this. Obviously, they don't give this type of question. So here, as the current are in the same direction, we add the two mutual induction. Here the current are opposing, so we subtract the two mutual induction. Now we know induced EMF is minus L di by dt. So I can multiply it by minus di by dt minus L1 di by dt minus L2 di by dt minus 2m di by dt. So what we have, total EMF equivalent, EMF due to the first inductor, EMF due to the second inductor, to EMF due to the mutual induction. Okay, done everyone?
Done, sir.
Similarly for here, I can write minus L di by dt minus L1 di by dt minus L2 di by dt plus 2m di by dt. Why? Because minus of minus plus. So what we have, E equivalent, E L1, E L2 minus 2em. So done everyone? Everyone
Yes.
done? So that's it, your electromagnetic induction. So from the next class, we start a new chapter, which is very, very important, called alternating current. And believe me, I show you that chapter in my way. Okay, if you want to follow this with the book, you can understand. Okay, it is a very difficult chapter, but believe me, the way I show you, you just follow it. It's a very, very simple and very, very easy